Right, and let's make a start. So gave you this question to start off with, and I didn't actually tell you which topic this would involve because I wanted you to figure out which skill that you needed to use. Now here, we're asked to find the gradient of the curve. And we've given this equation y. So to find the gradient, we're going to need to differentiate, because remember, when I differentiate, I find my gradient function. So I'm just going to show you here the mark scheme for this. So we differentiate the following. Now the first term, we've got the root 2x squared. So when I differentiate this term, I need to multiply by the 2. So multiply by the old power. So that's where you get the 2 root 2. And then the power comes down by 1. So the x squared goes down to an x. Then we have the minus 6 root x to differentiate. Now remember, this is the same. The square root of x is the same as writing x to the power of a half. So if I do that, then I multiply by my old power of a half, so minus 6 times a half for minus 3, and then reduce the power by 1. So the half goes down to a minus half. So you can either write that as minus 3x to the minus half, or how it's been written here in the mark scheme. Instead of writing as x to the minus a half, you can write it as minus 3 over the square root of x. Both would be absolutely valid. And as you can see, the differentiating part scores you 2 marks. But we don't just want the general gradient function. This question wants to know what is the gradient at the point 2 to root 2. So we need to actually sub in our value of x to find out what the gradient is at that specific point. So we just put in x equals 2 here. The fact that y equals 2 root 2 at that point is kind of irrelevant for this question. Because we're differentiating with respect to x, it's the value of x that we need to substitute in here. So we substitute in x equals 2. Just the attempt to do that gets you a mark, and then you should end up with 5 over 2 root 2. So it wants it in exact form here, where you give that value of the constant a. So just be 5 over 2 would be the constant. So looking at the your submissions on the forms, thank you for everyone's done that. It's really important that you do that because it tells me, is this a question you're confident with? Is this something you need a bit more work on? So I can see a few of you gave it a good attempt, excellent, but didn't always quite get 5 over 2. So hopefully this explains how we did get that there. So just let me know if there's any questions on that first one. Otherwise, I will move on. So I'll just give you about 30 seconds if there's any questions there, and then we'll start with set notation today. Okay, can't see anything there, so I'll move on, but just please leave questions in the chat. Lane and Gavin are on hand to answer questions. I also will check the chat at certain points. So today we're going to look at set notation. So we've been using some of these symbols already, some of this notation already, but really it's just a nice roundup of that. And some of the problems that we've previously been looking at, now we're just going to write purely in this set notation. So it's really important to get your head around this, especially for things we're going to go on and do later in this booklet. So firstly, we've got this symbol here. Sometimes we use the Greek letter, I think it's called psi, but we'll check that. I believe it's called psi, or sometimes just a capital S to represent the whole sample space. That's everything in that rectangle. And from marking some of the assignments that you did from last week, make sure that you do draw a rectangle around all your circles for your Venn diagrams. Okay, it's important that you do that. You will lose a mark if you don't have that rectangle. Even if everything else is perfect, it is important that you have that. So we looked at last week, if we have the probability of A and B, that this just reflects this part in the middle. Okay, so if I want to look at the probability of A and B happening, it's just this bit in the center here between these two circles. Okay, that's where A and B are both happening at the same time. We also learned last week that if the probability, if A and B are independent, if we multiply those probabilities together, then we get the probability of A and B. So that's an important definition you need to use. We're going to use that later today. And that's that if it's independent and we just do the probability of A times the probability of B equals the probability of A and B. And remember, if A and B are mutually exclusive, it means they cannot happen at the same time. So in that case, if they're mutually exclusive, then the probability of A and B happening at the same time is 0. If you draw the Venn diagram, if A and B are mutually exclusive, the circles won't overlap. Then we have the probability of A or B. What this means is at least one of these events needs to be happening, but not necessarily both. But both could be happening as well. So in this case, I would just shade in all of this, because here in all three of these sections, either A is happening and B is not, B is happening and A is not, or A and B are happening. In all three of those scenarios, at least one of those is happening. So also worth remembering that if they're mutually exclusive, however, the probability of A and B would just equal the probability of A or B. That's only and only if they are mutually exclusive. And then finally, we met the not A scenario. Okay, so if it's not A, we just put a little dash there to say that it's not A. So what we'd do here is, in terms of shading this area, is we would just look at everywhere where A is not happening. So think of it as, well, what would I shade in if A was to be happening? Well, that's the only thing I'm not going to shade in. So moving on then, so using this notation, so this first question is very similar to one we did last week. But now with the set notation, okay? So we've got cards selected at random for a pack of 52 playing cards. Let A be the event that the card is an ace and D the event that the card is a diamond. So I'm going to draw my Venn diagram. Drawing that rectangle, okay, is important that you have all events happening there. I'm going to put an A for aces and D for diamonds. So in terms of filling out this Venn diagram, so we did a very similar example to this last week. There's only one king of diamonds. Sorry, ace of diamonds, sorry. So only one ace of diamonds. So I put a 1 in the middle there because there's only one card which is both an ace and a diamond. Now there's 4 aces in the pack, so I need to put 3 here. That 3 represents all the aces that aren't diamonds. Okay, so that whole circle adds up to 4 altogether. And then in the other one, I need to put a 12 there because there's 12 diamonds that aren't aces. And finally, I need to make sure I put my 36 on the outside to show the cards that are neither aces or diamonds. So going through all these 4 questions here, the first one, the probability of A and D. So that's A and D both happen at the same time. Well, that's just going to be 1 out of 52. There's only one way that event can happen out of 52 possible outcomes altogether. For B, this is the probability of A or D happening. So either you get an ace or a diamond. It doesn't have to be both. And this would just correspond to all the numbers in the circles here. So it's the 3, the 1, and the 12. I would add that all together for 16. And I've got my 52 outcomes. So that's the same as 4 over 13. Okay, all that means is the cards you've either got an ace or you've got a diamond, or it could be both. So it's just all those numbers in the circles there I add together. For C, we look at the probability that it's not A. There's two ways that you could think about this. You could simply just look at all the numbers that aren't in the circle of A, or you could just work out the probability of A and take it away from 1. So we could either do 1 take away 4 over 52, or we could just do 12 add 36 for 48 over 52. That is the same as 12 over 13. And then finally, we have the probability of not A and D. Now, for this one, I'll put the crosses in just to show you how this is working. So probability of not A and D means both of these events need to be happening for this condition to be met. So if I look at where A isn't happening, that's where I'm putting these black crosses now. And if I look at where D is happening, that's where I'm putting these red crosses. So the probability of A not happening and D happening, that's where the crosses are both there. And the only place where it's both there is for that 12. So it'll be 12 out of 52, which is the same as 3 over 13. Now, if you put that into words, this just means the probability that the card is a diamond, but it's not an ace. And if you know your cards, there's 13 diamonds in the pack, but one of them is going to be the ace of diamonds. So there's only 12 cards there that are diamonds, but not an ace at the same time. Right, if there's any questions, I will just quickly check the chat for any questions. Can't see anything at the moment. But please let me know if you do have any questions. So moving on to example 2, we're told that P and P is 0.3. The probability of Q, I should say. The probability of Q is 0.3. The probability of R is 0.4. And the probability of Q and R happening is 0.25. And we're going to explain why these events Q and R are not statistically independent. Now, if we recall from last week, to be independent, the probability of Q times the probability of R would have to equal the probability of Q and R. So what I'm going to do is I'm going to multiply 0.3 and 0.4 together. And when I do that, I get 0.12. Now note, the probability of Q times the probability of R has not given me the probability of Q and R. So I would just write the probability of Q times the probability of R does not equal the probability of Q and R, okay? For them to be statistically independent, when I multiply them together, it had to have equaled 0.25. It doesn't do that, so I can conclude the events are not independent. Okay, so then moving on to part B now. I'm told the probability of T is 0.2 and the events Q and T are mutually exclusive. So what this means is if Q and T are mutually exclusive, it means they cannot happen at the same time. So what you'll find there is that the circles don't overlap. So when I draw my Venn diagram here, I'm going to keep Q and T on these opposite ends here because they're not overlapping. They are mutually exclusive. Okay, and then R is just going to be the one where there is the overlap. We're also told that events R and T are independent. So what this means is the probability of R times the probability of T equals the probability of R and T. So the probability of R from part A is 0.4. The probability of T from part B is 0.2. So the probability of R and T is 0.08. What this means is, on my Venn diagram, where R and T are overlapping, I know that probability there is going to be 0.08. So let's fill in some other parts on this Venn diagram. From part A, I'm told the probability of Q and R is 0.25. So I can put in that 0.25 where Q and R overlap. I'm also told the probability of R is 0.4. So that means everything in that circle for R has to add up to 0.4. So I need an extra 0.07 there. So now that whole circle, all those probabilities add up to 0.4. And that's split between where R happens and Q and T doesn't, where Q and R are happening but T isn't, and where R and T are happening but Q isn't. Okay, so we're just splitting all those probabilities up there. For Q, you've got the fact that probability of Q equals 0.3. So we need a 0.5 there to make the whole thing add up to 0.3. And then for the T, we just need a 0.12 there, because the whole of that circle needs to add up to 0.2. The other thing I need to do is make sure that I put this number on the outside here. Okay, so the probability that none of these three events are happening. So I just simply add up all of these numbers and take them away from 1, which will just be 0.43. Okay, and with that, my Venn diagram is now complete. One thing I just want to point out here, just sometimes it's a misconception. Just because Q and R weren't independent, it doesn't mean they are mutually exclusive. Okay, Q and R, as we can see, clearly are not mutually exclusive because there's an overlap there of the circles, and also they're not independent. So it doesn't mean that just because something's not independent, it's mutually exclusive. Please don't confuse those definitions. They are different things. Just make sure you follow the formula that we've given you there to check if they're independent, to check if they're mutually exclusive. And then finally, we have this lovely looking thing for a Monday morning. The probability of Q and R not happening or T happening, that's what we need to find. Okay, so we're going to need to break that up a bit. The first thing I look at is the probability. So it's in bracket here. I'll just start off by finding what the probability of Q and R not happening is going to be. So to do that, this is where Q is happening and R isn't happening. So that's just simply going to be where I put this red cross here. Okay, this is where Q and R aren't happening. Okay, because if I look at that 0.25, whilst Q is happening, R is happening as well, and I don't want R to be happening. So it would just be the 0.05 there. Okay, and then also, so that's not the whole question. That's just looking at the probability that Q and R doesn't happen. But I need to find the probability that either this happens or T happens. So I'm just going to highlight where that's going to be the case. So this is where Q and R aren't happening. And then the other condition is that T happens. So it's either of these probabilities. So I add them all together. So 0.05 plus the 0.08 plus the 0.12, or I can just simply add the probability of T together. Remember, Q and T are mutually exclusive, so you're not going to see any overlapping there. And I just get 0.25 when that happens. Okay, so I'll just go back to the chat, just check if there's any questions. So just give you a few seconds just to copy anything down, and then we'll go back. So I've just had a question about the isn't R isn't that 0.08 coming from R happening? Right. So this is where it can get a little bit confusing. So because I'm only looking at an OR event here, when I do this bit, this means I'm looking at Q happening and R not happening. So I'm saying if Q happens, R can't be happening. But when I look at the whole thing, if I separate it and look at that first event of Q and R not happening, work that out first, and then treat that probability of T1 separately. In this case, only one of these events needs to be happening. So that 0.08, whilst that would not meet that first condition, because R would be happening, it meets the second condition because T is happening. So when I get to that OR bit, as long as one of the events happens, and you would be right in saying I would disregard the first event happening of Q and not R, but in terms of the second event, T is happening. So I can include that 0.08 in that part of the calculation. Right, unless there's any more questions, I will move on to the final part, where basically you've just got a lot of Venn diagrams to shade in. Okay, so some of these will be easier than others. So first one, we're just looking at B happening. So I don't think that one should cause any problems there. We just shade in the whole circle anywhere where B is happening. Okay, and then not B, basically look at the first one and then just shade anywhere where we didn't before. For the third one, I'll look at A and not B happening. So this one, I've got a bit more happening here, so I'm going to draw some crosses to show what is being represented. Where A is happening, I'm going to draw a black cross there. Where B is not happening, I'm going to draw a red cross. Because it's A and not B happening, I need to shade everywhere where I've got two crosses there. Okay, if I just shaded on the outside, only one of the conditions has been met. Okay, on the outside, it's just that B isn't happening, but I can't say that A is happening there, so I can't shade that. And the bit in the middle, whilst one condition's met that the A is happening, the B is happening as well, so that contradicts me saying that B can't happen. For 4, I look at not A, so I'm going to do black crosses for not A, and then for where B happens, we'll draw the red crosses, and then we can just see that that's just going to be this region here where both events that I want are happening. Then we have A or not B. Okay, so this is different than the last one. The last, for 3, we had A and B not happening. This is A or B not happening. So I draw my crosses like I did before for A. So this is where A happens. This is where B isn't happening. But this time, what I'm going to do is anywhere there's a cross, at least one of those events is happening. And because it's or, all I need to do is just shade in where at least one event isn't happening. Okay, so pretty much the whole thing except for where B happens without A happening, because they're neither conditions met. Then we've got 6. So I'm going to first shade in where A is not happening. Put the crosses there, sorry, where A is not happening. And then where B is happening, I'll put the red crosses. Because this is or, this time I'm just going to shade anywhere where there's at least one cross. And it will look something like this. On to 7 and 8 now, so it gets a little bit more tricky here as we go down the page. So firstly, where A isn't happening, that's these places here. And then where B isn't happening, that's here and here. Because it's and, I'm going to just shade in the outside. So if you're ever unsure, just think about why I wouldn't shade anything on the inside of the circle. If I shade in where I've got that red cross in the A circle, well, whilst B isn't happening, one of the conditions is met, A is happening. So for and, both things have got to be happening. So I couldn't shade in anything inside the circles here because at least one of those events would be happening, which would contradict what I'm trying to do here. And then I've got not A happening or not B for 8. So for not A, we'll just do this. And then not B, just do this. So it's the same setup as before, but this time I'm looking at an OR event. So I just shade in anywhere where I've got a single cross. So it's pretty much the whole thing. The only thing I couldn't shade in is this bit in the middle, and that's because that's where A and B are happening. So if I shade the bit in the middle, well, I can't say that A isn't happening because it is, and I can't say that B isn't happening in the middle because it is. So that's the only bit I can't shade in because for the OR events, at least one needs to be happening. It doesn't have to be both. And then finally, on question 9, so the best way to think about this, so I've got the bracket here and the dash around it. So the best way to think about this is ignore the dash for now. And if it just said A and B, that's just the bit in the middle. Well, this is the bit it can't be. So, okay, it can't be this section. So what I'm going to do is shade everything but that section. Okay, and yeah, again, you can kind of just go around and check certain sections and just think about it logically and go from there. And then finally on 10, yeah, again, if you ignore the dash, so I'm doing these dashes a little bit different how I've been doing these crosses, how I've been treating them previously. But here what I'm doing is ignoring the dash, thinking about where A or B happens. See, again, it can't be this. Okay, so it can't be these sections. So I'm just going to shade everything that isn't that. And there we've got all 10 done. Just a word of warning, hopefully you can see it from the diagrams here. You might be tempted to think that A and B in a bracket when you've got the dash would just be the same as A dash and B dash. But you can see from 7 and 9 that you actually get different solutions. So it's not just a case of when you've got the bracket, you can just put the dash on, just take away the bracket, put the dash on all of them. You can see that 7 and 9 are different, and then similarly, 8 and 10 are also different. So don't just think when you've got that bracket, you can just put the dash on each letter. It doesn't quite work like that. Hopefully you can see that from that example there. I will just check the questions. I haven't got any more questions, but I will stick around just to double check if there's any more. So just in terms of what to do today, so what you're going to do, go away and do now is have a go at exercise 2A that's been attached to this week's assignment for lesson 1. So there's going to be questions 4, 5, 6, 8, 10, 11, 12, which we want you to have a look at. If you could take a photo of questions 5, 8, and 10 and upload that to your assignment. If you have any problems, whether it be with the technical aspect of it, loading up to Teams, problem with the questions, we're all going to be on Teams all day to take any of your questions. So ask myself, Lane, Gavin, if you do have any questions, we'll be happy to answer them. When you upload your assignments, just make sure it's easy for your tutor to mark. So try and make sure the lighting's good. Make sure it's kind of clear what the question is. Just make it as easy as possible as you can for us, please. And yeah, as I said before, make sure you do ask away if you have got them, and also use the solutions provided to self-mark, but only to check, not just to copy, obviously. We want to make sure that you can do these questions. Right, are there any more questions before I go? Okay, I can't see anything. I'm going to stop the recording now.